In this video we are going to discuss the special properties of parallelograms and rectangles, and we're going to use those properties to find some unknowns. There are four things you need to know about a parallelogram other than the definition. So first of all, the definition is a parallelogram is a quadrilateral with opposite sides parallel. So these are parallel and these are parallel. But now some properties. Opposite sides are congruent. If this is 5, then this is 5. If this is 7, then this is 7. Opposite sides are congruent. Another property is that opposite angles are congruent. So if this angle is 40 degrees and this angle is 140 degrees, guess what x is? 40 degrees. Guess what y is? 140 degrees. Now, speaking of angles, consecutive angles like these are supplementary. Alright, notice they're not across from each other. They're not opposite angles like these or like these would be. So when you have two angles side by side, notice that one of them is obtuse and this one's acute. So there's no way you would ever think they're going to be congruent. But they're supplementary. That means they have to add up to 180 degrees. So what must be x? Well, x must be 70, since 110 plus 70 is equal to 180. Or I could think of it as, I could find x by doing 180 minus 110. That works equally well here. These are consecutive angles. If this is 60, what's x going to be? Again, I can think of this as 180 minus 60. So that means x is going to be 120. One final property is that the diagonals bisect each other. That means they cut each other in half. So this point of intersection is going to be the midpoint for both diagonals. So if I told you that this was 10 and this was 7 and we had x and we had y, then x would be 10 and y would be 7. Alright, because these two halves of the diagonal have to be equal and these two halves have to also be equal. Alright, now when it's a rectangle, the diagonals will be congruent. But if you have a parallelogram that's not a rectangle, you're going to have a long diagonal and a shorter diagonal. In this case, 20 and 14. So in number 14, the diagram shows the parallelogram-shaped component that attaches a car's rear view mirror to the car. In parallelogram RSTU, UR is 25. See if I can get this started. UR is 25. RX is 16. Angle STU is 42.4. Okay, STU. So that's this whole angle right here. Okay, is 42.4 degrees. And we are supposed to find these various lengths. For example, ST. Alright, let me zoom in. Okay, so we're supposed to find ST, but we know that opposite sides are congruent, so ST is going to be 25. Okay, what's next? We're supposed to find XT, but we know that the diagonals bisect each other, so this being a midpoint, RX is 16, so XT will also equal 16. Okay, last one. We're supposed to find the measure of angle RST. Let's see, RST is this angle right here. Okay, Now, this angle RST and the angle STU are consecutive angles. And we learned that consecutive angles are supplementary. So these two angles should add up to 180. So since this angle over here is 42.4, I should be able to calculate this angle by doing 180 minus 42.4. So that's 137.6. Alright, so that's it for number 14. In number 15, we're given that this is a parallelogram, and we're supposed to find the value of MP. So just be careful, we're not just finding x. We're going to find x, and then we're going to use that to find MP. So we're going to find x and then substitute that back in. Well, these two expressions are opposite sides, so we know they will be congruent. So for that reason, we can set them equal to each other. So we know that 5x should equal 3x plus 12. And the minute I see the same variable on both sides of the equation, I want to get those together, in this case by subtracting. So that's going to give me 2x is equal to 12. And then I'm going to divide by 2 on both sides. So that's going to give me x is equal to 6. Alright, but that's not the final answer. Alright, MP is 5x. So if I take this 6 and substitute it in, then what I have is 5 times 6. So that's why MP is going to be 30. Now in problem number 16, the diagonals of a rectangle ABC intersect at E. And then we're given some information and we're supposed to find some things. So we need to draw a sketch, but first let me tell you one additional thing about a rectangle. Okay, so here we have a rectangle and here we have a parallelogram. First of all, a rectangle is a special kind of parallelogram. So we talked about these special properties of a parallelogram and even the definition, so it's 5 things. All of these things still apply to a rectangle. Alright, so looking at a rectangle, the opposite sides are still congruent. The opposite angles are congruent. The consecutive angles are supplementary. And the diagonals bisect each other. But in addition to that, the diagonals of a rectangle are congruent. Alright, so the pink diagonal and the blue diagonal are congruent. So if I told you that this was 10, you already know that this would be 10 from a parallelogram. Alright, the diagonals bisect each other. But if this pink diagonal is 20, then the blue diagonal is also 20, which makes this 10 and 10 as well. So in a rectangle, if you have one of these 4 pieces, all 4 pieces are going to be the same, alright, because they are all halves of the same diagonal length. Oh, and the definition of a rectangle, of course, is that a rectangle is going to have 4 right angles. Okay, so separate from a parallelogram, the 2 new pieces of information you get when you see the word rectangle, 4 right angles, and the diagonals are congruent. First of all, it's called rectangle ABCD. We have to make our own sketch. So we draw some sort of a rectangle. Just understand, when you have a name, rectangle ABCD, it doesn't really matter where you put the A. Let's say I put it here. But what matters is you go in order around the rectangle, either clockwise or counterclockwise. So I couldn't go A and then B like that. That would be wrong. But I can go A, B, C, D like that. As long as I go around, then it should work out. Now, more information. They say the diagonals intersect at point E. So we need to draw some diagonals in here. So here's a diagonal. Okay, and just for fun, I'm going to color mine. Okay, so there's a diagonal. And here is another diagonal. And they intersect at point E. So this will be point E. Given that the measure of angle BAC is 51 degrees, so BAC, that's this angle right here. Okay, so this is 51 degrees. AC is 23. Alright, AC is this diagonal. Okay, so this whole thing is 23. Alright, so I'm trying to keep the diagram from getting too messy. But this is the 23. And BC is 17. Okay, so this is 17. Okay, we're supposed to find the indicated measures. So for example, we're supposed to find the measure of angle CAD. Well, angle CAD is this angle right here. Now you know that these two angles have to add up to 90 because it's a rectangle. So if I want to find CAD here, I could simply do 90 minus 51. Alright, so that's 39. So there you go, 39 degrees. Next, we're supposed to find BE. Okay, so BE is right here. It's this length. Now the pink diagonal is 23. That means the blue diagonal is also 23. So BE here is going to be half of that. So to find BE, I'm just going to do 23 divided by 2. Alright, and that should be BE. So that is 11.5. Alright, so BE is 11.5. Which, by the way, means all four of these pieces are 11.5. Alright, next we're supposed to find the measure of angle ACD. Alright, ACD is this angle right here that I just marked in triple purple. Now there's two different ways to think about it. I like to see the Z when I'm dealing with parallelograms or rectangles. And there's a Z happening right here. And the reason why I like to see the Z is because they help me see alternate interior angles. And of course these lines are parallel. The diagonal is a transversal. So alternate interior angles should be congruent. So for me, that's the quickest way to see that this should be 51 degrees. Alright, the other way to look at it, if you weren't going to do the Z thing, a minute ago we figured out that this angle right here was going to be 39 degrees. And you know that this angle right here is a 90-degree angle. So if you look at this triangle over here, okay, if you look at that triangle, you know that you can either say all three of these angles have to add up to 180 degrees, or if you know sort of the shortcut that since this is 90, then these two angles have to be complementary. These two angles have to add up to 90. So the thing that you could do is just either subtract these two from 180, or what I would do if I was going to do it this way at all, I would subtract from 90. So I would do 90 minus 39 to get this angle. Alright, of course that's going to be 51. So either way, you're going to get 51 degrees. Okay, and now we need to find the measure of angle DEA. So where's that? Okay, DEA is this angle right here. Okay, so if this is angle DEA, okay, that's the angle that we're looking at, that we need to find. The thing to do is to recognize that each of these small triangles going around the rectangle, each of these four triangles that are meeting at E, are isosceles triangles. Alright, because of the whole thing about the diagonals being congruent and bisecting each other, and how these four will all be equal, like 10, 10, 10, 10. Hopefully you can see that that sets up a situation where you have a bunch of isosceles triangles. If this is 10 and this is 10, you know, that means these are congruent. And remember that in an isosceles triangle, the base angles will be congruent. So these sides are congruent, the angles are congruent, isosceles. So that's what's happening everywhere in this rectangle, isosceles triangles. So that means, for example, this angle over here is also 39 degrees. Alright, because these are isosceles triangles. So we have 2 out of 3 angles in a triangle. If we want to find the third, we will subtract from 180. So we can do 180 degrees minus 39 minus 39. Okay, so 180 minus 39 minus 39. So that's going to be 102 for angle E. Well, DEA. Alright, now this last question here, what type of triangle is triangle BEA? Well, we just emphasized that. Okay, BEA, as well as the triangle we just did, and all 4 of these triangles meeting at the center, they are all isosceles triangles, as we just discussed. Alright, that's going to do it for this video about parallelograms and rectangles. I hope it was helpful. I will see you on the next video.